next is two-way or punching shear in footings. So the shear acting all along the perimeter of a column can punch the column in the footing slab and is called two-way or punching shear. So here we can see the diagonal crack appear on both sides or on the fourth side of the column, and the column will be punched out of this slab, and this appear all along the column. So this type of shear is termed as two-way or punching shear. The punching shear failure or two-way shear failure is critical around the column perimeter at a distance d by 2. So in case of two-way shear, we consider the critical section at a distance d by 2 from the face of column. So here the distance from the face up to this critical section is d by 2. D is the effective depth of slab. And the applied shear can be calculated, applied two-way shear can be calculated by multiplying the contact pressure under this foundation or under this footing slab multiplied by the area of footing outside the critical parameter. So if we see QU multiplied by, this is the total area minus the area of footing inside this critical section. So this area, this unshaded area. So if we subtract this unshaded area out of this total area, we will get this shaded area, and the load acting on this shaded area will cause two-way or punching shear. Okay, next is how we can calculate the capacity of the footing slab against the two-way shear. So we can calculate the capacity or the strength of concrete against the two-way shear by using this formula. This is these three formulas, and the lesser out of these three will be considered. So these formulas are specified in ACI code, and we have studied these formulas, or we have studied the concept of two-way shear in detail in case of direct design method. So here if we see, we have B naught and D. So B naught is the critical section perimeter, D is the effective depth, B is the ratio of longer to shorter side of the column, and alpha is a factor which is 40 for interior columns, 30 for edge columns, and 20 for corner columns. So by using these three equations, we can estimate the capacity of concrete against the two-way shear. And here lambda is a factor which accounts for the lightweight concrete. In case of normal strength concrete or normal weight concrete, its value is 1, but for lightweight concrete, its value may be 0.75, or we can select the value if we know the density of concrete. So depth of footing should be such that, or we need to satisfy this equation, so which is the shear capacity of the concrete slab against punching shear should be more than the applied punching shear. So to satisfy this equation, we need to play with the thickness of slab. So we need to select the thickness such that this equation or this condition is satisfied.